Okay, now we can use some of the information about Ks to determine whether a precipitate will form. Typically this is asked in regard to two separate solutions being combined, for instance in this case sodium fluoride and calcium nitrate. And you may be asked, for instance, that will a precipitate of calcium fluoride form? And you can always tell the precipitate you're interested in because a Ks value will be for that precipitate, in this case calcium fluoride, where I've shown the equation here. Okay, so we have two separate solutions that are not forming a precipitate at the moment. This contains calcium ions, nitrate ions, and this separate solution contains sodium ions and fluoride ions. So well, what happens when we combine them? Will a precipitate between calcium and fluoride form? Well, we need obviously to know the concentration of the calcium ions and the concentration of the fluoride ions. And so, and instead of calling the product Ks, we call it the ionic product. In this case it's going to equal the concentration of the calcium ions against the concentration of the fluoride ions, and that's going to be squared. So I'll just rewrite this just in case it's not visible on the screen. It seems to be going off a bit. Fluoride ions squared. Okay. Now the reason we call this the ionic product is because when we put the concentration in here and we put the concentration in here and we square it and we work that out, if that number ends up being greater than the value of Ks, the constant, the precipitate will form. Because obviously we may have very, very, very small amounts of fluoride and very small amounts of calcium, and that may not be enough to actually even cause a precipitate. But when we put the numbers in it and we multiply them and we do the calculation, we call it the ionic product. And as soon as that combination goes above Ks, the constant for that temperature, it's going to cause a precipitate to form. Okay. Now, there are some complications to this. One, for a start, this concentration here, 2.5 times 10 to the negative 3, as soon as you combine 100 mils of this into 100 mils of this, you have diluted it. Just the same as if you took 100 mils of Coca-Cola and added 100 mils of water to it, you would have diluted it. It would not be the same strength as it was before. Now, so you have to recalculate these concentrations, taking into account that it has changed. Now typically in NCA they have easy ones where it's basically dividing the concentration in half. For instance in this case, like this, 100 and 100. So that would be dividing this in half, would be 1.25 times 10 to the negative 3, and this would be 2.05 times 10 to the negative 5. And so we go IP equals, now the calcium ion, which is going to be 1.25 times 10 to the negative 3, and the fluoride ion, which is going to be 2.05 times 10 to the negative 5, and that is squared. Now we don't have to do anything fancy to this. This is the concentration of the fluoride ions. We don't have to double it or do anything weird. They've told us the concentration. The only thing we have to do is divide it in half because we've combined 100 mils and 100 mils. Okay, that's all we have to do. So when we work out the ionic product, which is going to be, just a second, it's going to be called 3.4 times 10 to the negative 11. Okay. Sorry, there's a little bit of an error there. I just wrote down the wrong number. That should be 5.25 times 10 to the negative 13. At this stage we recognise that that number here is smaller than this number. Okay, it's a negative 13 and that's a negative 11. So as IP, and you must make the statement, is less than Ks, a precipitate will not form. Okay. Now obviously if it was bigger than that number, precipitate would form. Okay. Okay, now lastly, just one minor point about this, because you're not always going to be asked where the volumes may be equal. Say for instance, if you had 50 mils of silver nitrate at this concentration, that's moles per litre it should be, and you're going to combine it with 100 mils of potassium chloride of that concentration, and asked whether a precipitate of silver chloride would form. Now you'd need to put the volumes into, oops, I shouldn't put S. It would be a case of your ionic product would equal the concentration of silver times the concentration of chloride ions, right? The main point of this though is, how do you calculate the new concentration? Because you need to put this concentration in, but it's got to be corrected for the fact that you've now combined it from 50 mils and you've added 100 mils to it. Now that's the original concentration of silver nitrate, so that goes there. And the original volume of it was 50 mils, and that goes there. And then you put that over the combined volume, which is going to be 100 plus 50. Okay? So that would be something like 1.2 times 10 to the negative 4 times by 50 over 150. So it's going to be 1/3 the concentration. Okay, so I'm not going to worry about doing the calculation. Notice I don't have to change from mils to litres or anything like that, because this is just a ratio here. That's all it is. And once you understand that, you can work it out. Now the new concentration of this one, which you'd also have to calculate, would just be 1.56 times 10 to the negative 6 times by 100, because there's 100 mils there, over 150. And that would equal the new concentration of the chloride ions. Okay, so that's how you work out when it's not even volumes and it's not as simple as dividing in two. Okay, now one final piece of advice in this, and that is, when you're asked to do a precipitate one, write out the actual equation you're going to be using. For instance, IP equals and whatever it might be. So in this case it would be silver and chloride, and then just realize you've got to put those concentrations in to calculate. Writing out the expression first helps you a lot in aqueous chemistry and getting a start on questions. So don't sit there wondering what you should do and all these different numbers and things. Write the expression and realize what you've actually got to start calculating. Okay?